So welcome to this session on Introduction to JavaScript. Right? Here we are going to talk about variables and values. Right? So first I'm going to start from value. What is a value? Right? Value. A value, the simplest way to look at value is that a value is a quantity. Right? Something that you are using to quantify something. So you can look at money, right? So you have $100. That 100 is quantity, right? You can look at it as a place, right? Then you say Brazil. You are looking at something in your head like that, Abby. When I say Brazil, you can attach it to an idea, right? The value is a quantity. It can be anything that you want to hold, right? So you can look at money, right? You can look at volume. All these are what? Value. What? No, I'm not writing. I'm just using an example. I'm not talking about that. So you can say $100 like this, right? You can say Brazil like this, right? All these are values. Now, when we hold a value, we have plenty of type of values in JavaScript, right? So we have integers, right, or numbers. So we have numbers, right? So numbers are primarily, they can be of type integer, of type decimal, right? So you can say 23 is a number, right? 3.142 is a number, right? etc, etc. These are numbers, right? That's a pi. That's pi, 3.142.
That decimal.
Yeah.
The software I saw that I don't know whether is it in JavaScript that it doesn't read decimal.
No, it reads it. It understands it. That's not issue with decimal. It understands it. So all these are called numbers, and their type is a data type, right, of value, right? We have another data type. Currently, I'll make it simple. I'll call it string, right? String. This is anything that is inside code like this. When you put anything inside a code like this, it is what? A string. Like now, when I say type of, so I'm introducing something now, type of 1, it tells us what is what? Number. Because 1 is a number. But when I put that number inside a string, inside a quote, it becomes what? A string. So these two are different types. One is a number, one is a string. So anything inside a quote like this is what? It's a string. What do we use strings for? We use strings to hold values, right? Any type of value, right? Especially name of something, right? So we have other data types, right? You just mentioned them. Array, right? Objects, functions, right? Boolean, null, undefined, not a number, right? All these are data types. There's symbol. We'll still come to symbol. There are plenty, right? We have looked at number, we have looked at string, right? Boolean is a state, right? We usually call it what? True or false. 1 or 0, right? The light is what? On or what? Off. The light, right? The car can be stationary or what? Moving, right? So when the scenario is one of the other, then we say it is what? Boolean, right? Boolean. So let's hold this for now. We'll come back to all the data types later. Now you see, when you have a data type, you must store it somewhere. You must hold it somewhere, right? You have a data, right? The values that we are looking for is a data, right? You must hold it inside somewhere. And that somewhere is where we come back to what? Variables. And what is the job of variables? To hold or store what? To hold or store values. They will hold or store values. All those values that we have talked about. These variables will hold them. So currently in JavaScript, right? We have two types of variables. We have temporary variables. Temporary variables. And so temporary variables, we denote it by, is it how to spell temporary? We denote it by let. It's correct, Abby? Yeah, it's correct. We denote it by let, right? Let. So let here says, once you create that variable, you can change it after that. It is changeable. It is changeable. That's one way to look at it. It is short, changeable. Once you create it, you can what? Change it. That's what we mean by what? Temporary. And we denote it by what? Let. So I can say let name, right, be equals to Biola. Yeah, we can say, so we can now say name equals to Toby. Now, if you check the name, the value inside name is what? Toby. It is now Toby, is no longer Biola, right? So this is what? This is a temporary variable. You can continuously change the value that is stored inside that variable. So here, this is the value that is a string. This is the variable that is storing this value. And this variable has been declared to be of type let. So it is what? Temporary. The other one is what we call permanent variable. Yes.
What's the difference between let and var?
I'm coming. So const is not changeable. Let's just hold it as not changeable. There are technical implications of them, but for now, just hold it as what? It is not changeable. So it's not changeable here means that when we now have let k to be equals to 2, right?
Why
We
do
can.
let?
Oh, sorry. I've already used let, so let me use const p to be equals to 7, right? I've already used k to be let. I can't change it to. So now I want to say p should now be 9. I'm going to get an invalid assignment error because it is constant, meaning that throughout the life cycle of that scope, right, it cannot change. The value cannot change. It should remain that. It is not what? It's not changeable, right? Now, there is another one that I refer to as general variable, which is what? var. Now, I want you to understand that var can behave like let or what? Or const, right? Now, var, when JavaScript was designed, we originally only had var as the only way to create variable, right? Let and const were introduced to JavaScript later. They are in new introductions to JavaScript, right? I want to, when let and const introduced to JS. No. So let and const are new additions to JavaScript. var was the only one that was available before. So currently we no longer use let var. Some of the reasons is because of what we call variable scoping. So this one reason why we don't longer use it is what we refer to as variable scoping, right? And we'll come back to it when we talk about functions, right? We'll talk about functions. When we talk about functions, we'll talk about what is variable scoping and how VAL is causing issues there, right? So currently, going forward in this session in our class, we will only be using what? We will only be using length and cost. We won't go back to var. We won't be using it. But I'm introducing it here because when you are reading older codes that have been written maybe 10 years ago of JavaScript, you will see a lot of var, right? So that you don't get confused. Or if you read code from jQuery library, you see a lot of var there somewhere here, right? So these guys will use a lot of var.
You can change the values of var.
Yeah, you can change the values of var. Yeah, it has, but I'm not going into it because we are not going to be using it here. That's why I'm not talking about it. So we have these two, right? And I've shown you that we have several data types, several value types, right? And then we have just two variable types that we are going to be focusing on, right? Let and const, right? So hold those two, just hold them in thought, right? Now, since we are talking about variables, right? I want to take a break. I want to take a break, right? To talk about how to write variables, how to create your variables, right? Methods to write your variables. So let's go. Here, number one method I want to talk about is what we call the underscore case, right? Underscore case says that you have a variable, right? And so let's look at a piece of code. I'm going to come here. We are trying to create a variable to hold countries in Africa, right? That means all the countries in Africa, isn't it? So how are we going to write it using underscore? Underscore says we should try something like this. What are the words? Countries. Countries in Africa, right? So rule number one, irrespective of the style that you are going to use, rule number 0 is that what? Never put space between your variable names, right? Doesn't matter whether you are creating a variable for your file or inside JavaScript, never put space between your variable names, right? The reason is this. When you put space, right, the browser that is going to read it, right, has to cater for that space that you are putting there, right? And you are leaving it to chance of how it is going to read that space, right? It becomes complicated. Do you get?
Yeah.
For the browser, for the system that is going to read it, all of them, they start to get confused. That is one. The second thing is this. The second thing of why you should not put space. So let countries in Africa, right?
Yeah.
Countries, I'm putting space now, in Africa, right, equals to 2. Where is this 2 going to be stored? Countries in Africa. So if I call countries in Africa now, I'm holding that up. So if I call countries in Africa, I'm going to get an error, right? I'm going to get an error in. Why am I getting this error? Because when I called countries in Africa, right, you can see that the color code are different, right? Countries in Africa, the color code are different, right? Because it is expecting just one string, right? Everything should be together. Once it has seen a space like this, the compiler of JavaScript believes that these two are different, right? So this number 2, is going to be stored inside these countries, right? Now it doesn't know what to do with in and what to do with Africa. right? So rule number 1 says never put space, right? So we now have some styles that you can use to write your name in. Number 1 is what? You can use the underscore case. So for this one now, instead of writing it this way, you will say let countries, you put underscore. Instead of space, you put underscore Africa equals to 2. See, now there is no space, right? And it is more legible to read. Legible to read, right? There is no space, legible to read, right? You press enter. So when you check countries in Africa now, you can get it. Can get the value 2 out of it, right? That is. So this is one style where instead of spaces, you put what? You put underscore, right? The next one is instead of spaces, you don't put any space at all, you don't put any underscore, you just make the next word, the last letter, to start with capital letter. So we call it camel case. Camel case. So this is countries in Africa, right? The next one after that space should just start with capital letter. So now we have countries in Africa. We have something similar to this. Number 3, we call it Pascal case, right? Or snake case. I'm coming. So if you look at Pascal case, right? Now this is camel case. As you can see, all the letters after are coming in. So here, the Pascal case, what do you notice about the Pascal case? The first letter of P, the first letter is capital letter, not just every other word, right? The first letter is also capital letter. So unlike camel case here, where so in iPhone, you have seen the iPhone. Look at how they wrote iPhone. Small letter I, capital letter P in iPhone. eBay, small letter E, capital letter B, right? This is what? Camel case. So let's go back here. So in Pascal case, everything will be capital, every word should be capital letter. So we have what? Countries in Africa. Like this. Countries in Africa, right? Now, so these are the styles that we have, right? The popular styles. There are plenty styles. But there's no error. Where is error? There's no error. You just drop down. Now, these are the popular styles that we have, right? So let's do so let countries in Africa now. It went away. What happened there? Let countries in Africa, right, should be equals to 6, right? If it is equals to 6, you can call it back, right? You can just say countries in Africa. No, not this one. I'm not calling this one. Countries in Africa, that's the second one. And it will return 6 for me, right?
But aren't they the same thing?
They're not the same thing. I didn't write them the same way. So one thing is JavaScript is case sensitive. It is case sensitive, right? Sensitive, right? So if I write countries in Africa, it is very different from countries in Africa, right? But then apart from that, this one now in underscore case, I am adding extra characters. Underscore. This one doesn't have underscore, so that one is even much more glaring, right?
Yeah.
So they are not the same thing. And as this one too is not the same thing as let countries in Africa, because now the case is different. That first letter is different, right? Countries in Africa should be 9, right? Now if you check countries in Africa, this one you see is 9. If you check countries in Africa, you see it's 2. Doesn't change because they are not related. And if you check countries in Africa, you still see it's 6. The 3 of them are not related. They are totally different variables like that. Totally different variables. They are not related to each other, right? So you can use any of these to create your variable, any of them. Now, they are conventions, they are styles, conventions, styles, right? They are not laws, right? So the only advice here is pick one, and stick to it, right? Stick to it. If you want to use camel case, pick camel case and stick to camel case throughout your program. If you want to use what's it called, Pascal case, pick Pascal and stick to it. If you want to use underscore, pick underscore and stick to it throughout. Don't mix it. Once you mix it, it is becoming confusing for you that is writing the code. For the person that is going to read the code, it is going to be what? Confusing. The only one that you can mix with any of these three is the number 4, right? That I call the constant case, right? This constant case, we use it to create constants, something that you know that will not change, like constant now. So when you create a constant and you know that that constant will not change, you make it capital letter, right? So it is a constant, right? Number of countries in Africa, that is a constant. It doesn't change. Does it change? It's 53. Abi? That number, it won't change throughout your program. It's 53. So when you want to write it, when you write number, so you write it like this. Number, you put underscore of underscore countries in Africa, like this, right? So here you can see it is still Pascal underscore case, but now it is capital letter, right? When you put it like this, anytime you see capital letter in your code, you automatically know that what it is a constant and that value will not change. It just reflects in your, it's just a convention, as I said. So when you need a constant, you can just use this convention, right? And then when you need a variable, you use this convention. Those are the two ones that you can max. You can mix this with any of this, right? Any of them, but don't mix this one with this one, or this one with this one, or this with this. Don't mix those ones, right? You get. So once that is settled, so that as we are writing code now, I may be using camel case, but I'll be using it throughout. I will not change that camel case that I'm using. Or if I'm using underscore case, that's what I will use throughout. Except there is very specific reason why I don't want to use it at that point. Right? Okay. So as we have this now, we have set this our how to create a variable, right? We have set values, we have set data types of variables, right? Now, let's talk about expressions. Expressions, right? So expressions here is when we are having operations in JavaScript, right? Operations now is we have addition, subtraction, multiplication, division, right? Um, um, Not, modulo, greater than, less than, greater than or equals to, less than or equals to. Then we check for equality. Then we check for strictly equals to. We'll come to it just now. So let's look at each of these one by one. The primary one that we are conversant with is arithmetics, right? So you can combine two values together using what? Using any of these operations. Now, this thing, we can combine two values using any of these operations. Value like countries in Africa, this is a value. You want to combine it with countries in Africa. This is another value. You can use any of these operations to combine them together in one way or the other. No. We are still coming to concatenation, right? So you can combine them to operate them. Maybe that's a better word, right? Because you can use multiplication to operate them. Then that will be multiplication operation. You can use greater than to operate them. That means you want to check which is greater than among themselves, and then it will return Boolean true or false if something is greater than the other, right? So this here, this sign here, right, is plus, right? And depending on how you are using it will determine the purpose it will serve. Whether it is what? Addition or what? Concatenation, right? So addition is mathematical, right? For numbers. Concatenation is for strings, right?
Yeah.
And now you have to be careful how you use it. I'm going to use an analogy now, right? So we can say 1 plus 2. These are values that are using the what? The addition operation, and they will give us 3. This is what? Addition, right? This is using plus as addition there, right? Now, concatenation is when you want to combine 2 strings. So you want to combine Toby plus Adegoke, right? When you combine it, there it is concatenation. This is not addition now. This is concatenation. Now I want to combine, I want to put space, because when you notice that the answer does not have space. So here I am combining Toby with space, then combining that space with Adegoke, right? This is what? Concatenation. So we are going to get Toby, Adegoke, right? Now hold this, because there is an issue. And the issue is, it is going to be a popular issue that we are going to be expressing a lot, right? The issue is, if I make 1 to be a string, it's a string, right? It's a string now. And I do 1 plus 2 now. Is this addition or concatenation? This is concatenation. Because 1 plus 2, if it is addition, we return 3.
But you said concatenation is for string.
Yes, concatenation is for string.
But that is not inside string.
That 2 is a number. The 1 is what? Is a string.
Okay.
Now, JavaScript saw one of the operand to be a string. So it converted the second one to a string, then concatenated it. Right? Now, this is one of the behaviors of JavaScript. Why it is weakly typed. Right? Yeah, JavaScript is weakly typed. And we are going to be seeing a lot of this. We are going to be experiencing a lot of this, right? When you are collecting data from any user, the data will usually come as a string, right? You want to know how this is dangerous and why you should take care of this. In JavaScript, your data from your user will come as a string, right? Now, you want to send money to somebody, right? Are you with me?
Yes.
Yeah, sure. You want to send money to somebody, right? You ask the person to enter the amount they want, right? In your account number, in your own account. So let my account, currently your account contains what? You have 768,784 in your account. This is the amount in your, this is what? Amount. This is number in your account, right?
Yeah.
Now you ask somebody, you want to transfer money to somebody, right? And then you ask the person to tell you how much they want, isn't it?
Mm-hmm.
So the person says, constant, I want, right? The person says they want 20,000, right? But because you are collecting it in JavaScript form, right? This I want will come as a string. Are you with me? You come as a string. Now, what do you want to do with this 20,000? You want to remove it from your account, right? And send it to that person, isn't it? If you do, so before I do removal, right? Let's do addition. Let's assume the person is transferring it to you first. So to collect now, to collect, isn't it? That means you want to collect it into account. So you do my account, right? Plus I want. Abi, how much do you think will be in your account now?
Yeah, sure, so
The addition of the two of them? No. So if you check to collect in my account now, this is what is in your account now. It has concatenated, right? This is not what you want. What you wanted is that these two, the second one that is a string should be converted. Currently, this is the number and this is the string. What the operation you want to perform is what? Addition, not concatenation. So JavaScript currently sees one of these as string, so it has converted the other to string. But what you want is the other one that is a string to become an integer, then it should add. To become a number, then it should add, right? Then it should perform addition instead of concatenation, isn't it? Do you flow?
yeah.
So, what you will force JavaScript, you will remove that. You will remove that capability that JavaScript has. Because if you don't, this is going to happen to your account.
What if you do first I want like my account
Yeah.
and turn it into a string?
And turn it into a string. You still get this. That is essentially what is happening here now. My account goes to become a string, then becomes concatenated with I want.
I was thinking of changing this one, but you can't change the constant.
Yeah, you can't change the constant.
Let me see what you do.
So what you want to do is you want to convert the string to a number. So JavaScript offers us that capability to convert string to a number using what is called pass int. So it is to pass float, pass int. You remember from before when we say type of, right? And we put this now. You agree with me that this is not number 9. This is string 9, right? So if I pass int, right, of 9, the data type of what is returned here, type of this, is number, right? Now, if I pass in string of it too, it is still returning number. Do you get? So whether you put normal number or you put string of that number, when you pass int of it, you are going to get number out. Right? Okay. So that is what we are going to do for I want. I want is currently string number, string 20,000, right? Yes. So this computation, we are going to perform it again. Now, instead of getting us this, which is wrong answer, right? Which is a terrible answer, which is going to cause conflict in your own data, right? We are going to perform pass int on it. So we are going to do to collect. I can use to collect now because I created it to be a let variable, temporary variable. That's why I'm able to reuse it. My account, right? Plus pass int, right? Of what I want. So I want will be converted to integer instead of my account being converted to string.
Will it be the same if you pass it of 20,000?
Yes, now. But it's not 20,000 that we want to change, and we cannot change 20,000. We cannot change I want because I want is a constant. Right? So here we are not changing I want. We are not changing because I want here is a string. Right? We cannot do anything with that thing. We cannot change it from string to number. That means you are already changing this constant here. So what is happening here is that I want will give us string. That string is what is going to be passed into pass int, this function here. So this function, what it will see here is 20,000 string, right? That 20,000 string will be converted to integer, right? The integer will now be added to my account, that is another integer, so that you will get the correct answer instead of getting this string here. Do you see the change in interaction here? Originally, this was converted to string. then concatenated with this. We have come to the agreement that that computation is wrong, right? So we need this one that is the string to be what? To be the integer, right? Because it is now the integer, because once it becomes the integer, it can now be this operation, instead of it being concatenation, it becomes what? Addition. So plus, operation plus, right, is an addition or concatenation based on where you use it, how you use it, that will determine which one it will be, right? So you have to be careful when you are using it. So to avoid confusion, if you are performing operations that involves addition, before you do that operation, what I will do next is to, for safety reasons, pass in everything, right, of my account. So whether my account is a number, I wouldn't know, it doesn't care. I will know that at the end of the day, I will get number, right? Pass it of what I want. I wouldn't care too. If I want was originally a string, it will at the end of the day, I will get number. So I will know that I am rest assured that what? It is number plus number that is what? Adding.
So passing remove strings.
Passing what?
Remove the string.
Yes, it will remove the string.
Like that what is used for.
Yes, that's the only job it does. For example, now I'm going to collect something here. Constant age, right? I'm going to prompt and I'm going to say, what is your age? Right? Now look at what happened. What happened there? There's a pop-up, Abi?
Yeah.
If I type anything here, as I said earlier, whatever input you are collecting from your user is going to come out in the form of what? Anything I type here is going to be a string. The end result is going to be returned as what? A string. So if I type 5, when that 5 is going to be stored here, it is going to be stored. You know, I'm typing 5 here, it is going to be stored as a string inside here. It is not going to be stored as a number 5. It is going to be what? String 5, right? If I type 20, you can type anything here. You know, we don't have any restriction here. You can type, why do you want to know my name? Right? You can type anything there, it will accept it. Whatever you type here is what is going to be stored inside this age, right? So for now, we can just put 40, right? When you put 40, so that 40 that we typed here has been stored inside this age. So if I do type of age now, right, it is a string, right? It is dangerous for me to just go ahead and say, because they are typed 40, and then I want to use this age and say age times 2. We have not got into multiplication, right? And just say age times 2 or age plus 7. If I do age plus 7, it is concatenation that will happen. It is not addition. So what will be the result? So what age is what? That is 407. So that will be 407 that will return. But it is not 407 we want. It is not concatenation that we want. We want addition. So before you perform this kind of operations, you do what? Except you are intentionally wanting it to be a string. You pass in age, then you add what? 7. So the first one will be what? String of 7 will be converted to what? Number of string of age will be converted to number of age that will now be added, addition to what? 7. You're not going to get 47. You flow with me?
Yeah.
So this is why I'm saying be very careful when you are dealing with addition. Right? You flow with me?
Yeah.
So the next one we want to look at is subtraction. Minus. Subtraction. Right? Operation subtraction. Operation of subtraction doesn't have that more issue as addition. Right? Subtraction is always subtraction. Right? So subtraction is always working on numbers. Right? If subtraction takes age is still a string, right? It's still a string, right? So if I do age minus 8, we are going to get 32. There is no string of subtraction. Subtraction is always for numbers. So here, the age will be converted to number automatically, and what? Subtract, and 8 will be subtracted from it. If it were addition, it will concatenate, right? So we don't have this. But then, just to be extra cautious, before I perform any mathematical operation, I convert it, pass int first. Whether it is addition, subtraction, multiplication, I make sure I convert it first. So I will always do pass int, just so that JavaScript does not behave irrationally, right? I'm still going to get the same result, but I am confident of this, that this is what? Number to number, right? Unlike this one, where it is JavaScript that is converting string of age to number of age for me. I am in control. In one, I am in control. I am certain of what is going to happen, right? In the other one, I am not certain. I don't know what is going to happen. JavaScript is in control, right? As much as you can, this thing that is happening here wouldn't have happened if JavaScript was a strongly typed language. Yes, it wouldn't have happened if JavaScript was a strongly typed language. Now, that is why, as we go through on in our class, you will realize that we are going to be encountering this kind of, that fundamental flaw. It's not flaw, because people have now embraced and understand JavaScript to be that, right? But the fact, yeah.
This thing, he did it at the beginning when he first created JavaScript. Why hasn't it still been changed now?
It hasn't been changed because they have now come to accept it, that it doesn't need it, that JavaScript is unique in that way, right? But some people have come to refuse the fact that JavaScript should be weakly typed, right? So they now went to build their own language. It is not an entirely new language, right? It is JavaScript, but now what? With type. Do you get? It's still JavaScript, but the only difference now is what? It now has type, and they call it what? TypeScript. In the definition of TypeScript, look at it when we open it. TypeScript. In the definition of TypeScript, you will see it there. Typed JavaScript at any scale. Right? It is the same JavaScript that we are learning here. Right? The only difference now is to avoid all these issues that we are experiencing of typing, data typing, of having to undo typing, right? And having JavaScript behaving weirdly with types. That is where we now have this TypeScript. Right? So you can write TypeScript that will give you all the types. So you still want to write JavaScript, right? But you need that typing. To avoid all this kind of confusion that we are experiencing here, then you can just write TypeScript. When you write TypeScript, we call it transpile, right? You write it in TypeScript. The end goal is that TypeScript will be converted back to JavaScript, right? But now you are confident it has type, right?
Yeah.
So originally it wasn't designed into it. Some people wanted it, right? So they now decided to design their own into. So it's like we want to write JavaScript, right? But we also need that type, right? So now they added their own type to JavaScript and then they created it, right? But when you write TypeScript, understand that TypeScript is still coming back to JavaScript, right? When you write it, the end goal of everything that you're writing, it is going to be transpiled back to what? JavaScript. The end goal. We'll still come back to it, right? But so TypeScript exists for those people that you get now, right? It's not only TypeScript though. There's CoffeeScript too. Before TypeScript, there was CoffeeScript. CoffeeScript. It was supposed to serve the same job too, right?
The same job of TypeScript.
Yeah, the same job of TypeScript.
Then
This
why-
one came first. So some people did not like it. They built their own TypeScript. But now TypeScript was designed by Microsoft. Microsoft that designed TypeScript. Is a tool of Microsoft, right? They are the one that built it. They are the one that designed it. Coming through, right? So you have to take care of this, right? Assuming you are writing TypeScript, it would have been automatically taken care, right? You would know that you have to look out for it, right? But now your second nature will be telling you to look out for it in JavaScript, right? So forget TypeScript, forget CoffeeScript. We are not dealing with those ones yet. So forget about them, forget their existence. Just focus on JavaScript, right? Let's go. So we have talked about addition, subtraction. Let's look at multiplication, division, right? Multiplication, division, age. So here, let's do multiplication, right? Multiplication too has two behaviors. Age is a string, right? Times 2 is giving us 80, right? It's giving us 80, right? Now, this is a string. Jog, this is a string, right?
This age times 2.
Yes, now, age is a string.
I know that if you write before where you called it out, will you still do the same thing?
Where I called it out, where?
I think age.
Age is a string.
And you did prompt.
Okay, that prompt.
Age was now 40. And I'm saying if you type this age before that prompt.
Before which prompt?
This prompt here. Like maybe you
I should run this thing again.
No, probably type age before this.
If I run age before this,
yes,
the age does not exist before now. If it does not exist, it is going to give us this thing undefined. If you write like now, James, right? James does not exist, right? Because there is no variable called James. So it is going to return what? Not defined. That is why you are saying undefined here. Because what? It is not defined. It doesn't know what it means. It doesn't exist. Until now, James now exists. James is now a constant that is holding Agbalumo. Now, James exists, right? So if you check for James now, you are going to return Agbalumo inside it. That was what you asked?
Yes.
Okay. Now, James multiplied by 2 is going to return not a number. They are not compatible. That operation cannot work, right? Yeah. But age times 2. Here, what is the conversion that is happening here? The data conversion that is happening here.
String times a number.
Yes, string times a number. Data conversion happened. Where did it happen?
You change the string.
So age that is a string is changed to a number, right? Before it is now multiplied with what? A number, which is 2, right? I still wouldn't leave JavaScript to chance. If it were me, I would do it. Pass int of what? Age multiplied by 3 or something like that, right? To get that. I still wouldn't leave JavaScript to chance. I guess. Get? Okay, that works. So this is addition, right? Then we have division, right? We have division, multiplication. Hello. Okay, so we have addition, subtraction, right? We are dealing with that. So let's deal with the next set of issues, right? So we have dealt with multiplication, right? So division, right? So division is normal division, right? The only thing you need to take care of with division is you are not dividing by 0, because anything divided by 0 is undefined, infinity. It's not on the real plane, right? Mathematics. So you have to take care that you are not dividing by 0, right? Or you can, apart from this, so infinity is like not a number, right? So NaN, right? You get NaN when you are performing an operation that should return a number, but it's not returning a number. Like James is Agbalumo, string times 4. when you do multiplication, you are expecting it to be returning a number, right? So James is not a number, right? Since James is not a number, this whole expression will return not a number. This is also a data type, like this data type that we were looking at here. This ones. So you see, I wrote not a number before, right? So this is where not a number comes from, right? When in your operation you are performing, you are getting, you are not getting what you should be getting. Like now, if I do James instead of plus, now I do minus, I'll still get not a number. Infinity, there is positive infinity, negative infinity on the real plane, right? So we have so numbers, right?
Real plane as in
Is mathematics. Real plane. Do you do set in math? We have complex numbers, real numbers, we have integers, right?
the real plane.
Set of numbers. So the real plane is the set of numbers. Real plane numbers, right? Is the set of numbers that contain everything between minus infinity and positive infinity. Everything between them. Minus infinity to 0 to positive infinity, right? That means all the decimals, all the integers, right? They are all on the real plane. So the real plane is the opposite of complex numbers, right? So complex number is the square root of -1. That one is not on the real plane. So like now, this is real plane now. As I said, real plane is the opposite of complex number. So if I try to do, how do I do square root now? Square root, right? Square root of 4 will give us what? Will give us 2. If I do square root of -4, this is a real number now. We will call this a real number. This is not a real number. 2i, this is not a real number. This is a complex number, right? So you get the idea of real plane. So when I'm saying real plane here, infinity means anything that is integer number, right? That you can get, right? That's on this real plane here, right? The infinity is the extreme, the number that we cannot get to, right? So any number divided by 0 is always going to return infinity. Do you get? Why? Why did I say infinity? This is why. Now, this 6 now, right? 6 divided by, notice something. Why do they call it infinity, right? Infinity means a number too large that we cannot even imagine. That's the meaning of infinity, right?
6 divided by 0 is 0.
Huh?
6 divided by 0 is what?
Is infinity. Is too large. It's not a number. 6 divided by 0 is not a number. It's not a number. That's why they put infinity. A number too large that we cannot imagine. How? Let me show you. 0.0.0.0. No. 0.0000007. Right? Can you see this number? When I divided, how many zeros do I have here? 3. I have 4 zeros. 7 zeros, right? 707, Abi. Now, I want to remove just 1 0. Just 1 0. Right? I want to turn to 0. I'm going to 0. Like this number is, that denominator is smaller, right? I want you to be noticing how this guy is greater than this guy, right? Sorry, let me remove another number now. Do you see? As I get towards 0, this one I'm not tending towards 0. I'm tending towards 1 like this one, right? Do you know, you get what I mean by I'm tending towards 1 like this? Now let me get 10 towards 0. Can you see that as I'm increasing 0, this number, this one at the bottom here is increasing, right? Is reducing in size, in amount. This guy is smaller than this, right? And this one is bigger than this, right? As this guy reduces, this number increases, right? So as you tend towards 0, this guy will be very large. When you get to 0, it will be impossible as I'm increasing this number, right? Can you see now? As I'm increasing this number, so E plus 33, that means it has 33 zeros after it. That's what it means, right? And how many? So as I'm tending towards 0, that thing is what? Increasing. When I get to 0, it becomes too large that we cannot phantom, right? We cannot think about too large. We are not on 0. This is what? Times 10 raised to the power 52. That means after this number, 52 zeros are there. You cannot pronounce it, right? Too large that we cannot phantom. That's why we are getting 0 there. So when you are doing your calculation, ensure that the denominator is not 0. That's just what I'm trying to say there. Apart from that, let's go to the other ones and round this session up. So the other ones we want to look at are greater than, right? So 6 greater than 9, we are going to get false. It's returning Boolean, right? Unlike 8 greater than 3, this one will return true. It is true, right? Yeah, it is returning true. So these two data types are what? Booleans. We talked about true or false, on or off, right? Yeah. Moving or not moving. So that is this, right? So the variations to this, so this is greater than, less than, right? Yeah. The variation to this is greater than or equals to, less than or equals to, right? So greater than or equals to is 7. Is 7 greater than 7? They are equal. So because 7 is not greater than 7, that is why it is returning false, right? So how do I know that? Is 7, so this one now is 7 equals to 7? That is what we are asking here. Here is what? Is 7 equal to 7, right? Here we are testing for what? Equality. They call it equality. Equality. That's what we are testing for. Equality. Is 7 equals to 7?
We do 7 equals to 7. 7 equals to 7.
No, I'm not doing 7 equals to 7. No.
What is this 2 equals to?
I'm checking, is the one on the left equals to the one on the right?
Okay, so what do you call that?
That's what I call equality, right? It is different from 7 equals to 7, like this. This is not this here. So let me just to be confirmed, let me show you. 1 equal like this, we call it assignment. What do we use it to do? What have we been using it for? We use it to assign value. We use it to store value. To store value inside variable. That's what we use this one for. When you have 2 equal sign, we call it what? Equality. We use it to test if the left hand side is same, right? Is equal to the right hand side, right? That's what we use this to test, right? But this has one issue, right? It tests whether left is equal to right, right? But it only tests for value. It doesn't test for what? It doesn't test for data type. I'm talking rubbish. Let me show you. Right? 7 equals 7. What do we get? True. 7 on the left is what?
A number.
7 on the left is a number. 7 on the right is what?
A number.
Is a number. So they are what? Same data type, right? And we are getting true. What happens when they are not the same data type?
It will still give you true.
They still giving me true. But they are not the same. They are technically not the same. Right?
Yeah.
Do you get? They are technically not the same thing. And we are going to run into error. We are going to run into problems. If you are doing financial stuff, you are going to run into problems. You want to ensure that what they are being given is what you are testing for. Right? Equality. I don't get
financial stuff.
Yeah, when I mean, like if you are dealing with file transfer, money transfer, or something like that, or you are trying to operate people's financial money and stuff like
using JavaScript to do that.
that. And like companies that build banks with JavaScript and stuff.
But Java is JavaScript
And it's
that
JavaScript.
used to write. So JavaScript knows that it is not. It doesn't test for the data. So
Yes, now it
only run
doesn't
into
test.
error. If it knows.
No, there is like technical error. This is a technical error now. This is what we call, we call it semantic error. Semantic error, right? We talk about errors, we still talk about errors, right? There are generally two types of error. But this one is what we call semantic error. Semantic error is it is doing what you want, right? But not the right thing. It is not giving you error, right? What you say you should do it is doing it. But that is not the right thing that should be happening. Right? This is not right. Because the 7 on the left is not the same thing as the 7 on the right. They are not. One is a string, the other one is a number. Right? So, that is why they now introduced the third one, this one. So you should notice now, one is an assignment, one is an equality, the next one is called what? Strictly equal to. Right? This one too we test. To test if left hand side, right, is equal to right hand side. Right hand side. But it handles data type. Not but, and it handles or factors in data type, right? Do you get? Yeah. So that if I do 7 equals 7, I'm going to get true. Because they are true. They are the same, right? Left, number is number, right? Number on the left, number on the right. Value on the left, value on the right. They are the same, right? If I do string and I compare it with the number, I'm going to get false. This is right. Because they are not the same. Here, right? This is right. Do you get? Because they are not the same. So I should be getting what? False. Do you get? So going forward in this class, right? And when you are writing JavaScript, never use this. Don't use the 2. Always use the 3. This is also part of those QX behavior like we saw in addition, right? That you have to handle. Never use 2. Always use what? The strictly equals to. So that it will not just check for for value, it will also check for what? Data type. It is important that you are not just checking for value. So this is that, right? What brought us here? So what brought us here is 7 equals 7, right? They are the same, right? But we said that 7 is not greater than 7, right? So 7, is it greater than or equals to 7? Yes. So it is going to check 2 things. Are they greater than? No. But is it equals to? Yes. So if one of the 2 is equal, is true, it is going to return true, right? This is what is called here, what we are performing here is called the OR operation. OR what? Operation. The OR operation, right? That is what is happening here, right? And how do you know the OR operation?
7. What will come out with string 7?
If it's string 7. It's not correct now. So that's what I'm saying. If you want to handle this, you should pass int.
Okay, so this one you cannot do 3
You cannot do 3 equals to for this one, right? The way to do 3 equals to for this one is, I'm coming, I'll show you. Well, I'm coming. So this is the OR operator. The OR operator says when both of them are false, that is when the result should be false. Else, it should be true. I'm talking rubbish. This is what I'm saying. This is technically the OR operator, everything, but I want you to focus here, right? 0 means false. 1 means true, right? When it is 0, 0, it should be what? 0. When it is false, false, it should be what? False. Otherwise, it should be true. That is why false, then true to true. So here, when we do false or false, we are going to get what? 0 or 0 is what?
False.
Get false. It's returning because I'm using or here. I'm not going to use this. I'm supposed to use this. It's still the same or. It doesn't want me to use that one, right? So this is or operator, right? If otherwise, it should return true, right? So that is what is happening there. So if I do true or false, I'll get what? True. If I do false or true, I'll get true. If I do true or true, I'll still get true. Otherwise, the only time it will go to false if it's what? Both of them are false. So that is what is happening here. We first of all check 7. Is it greater than 7? It's returning false, abi? Or 7, is it equals to 7? The first one will return false, right? Or, which is this one, abi? The first one will return false, right? Or the second one will return true. Because one of it is true, it will return true. That is why we are getting true here. Right? That is, so this is the breakdown of what is happening here. Do you get? So they just, instead of writing this long one, they have compressed it into this here. So this is what? The OR operator for greater than or equals to, less than or equals to, stuff like that. The opposite of, there are plenty kind of this, we call them, I'm coming, I will remember their name now. But another one is the AND. The AND operator, right? So it doesn't want me to. No, not if else. AND operator, right? AND operator is the opposite of OR, right? So let me show you here. AND operator. AND operator says it should only be true, right? When both of them are true. OR says what? It should only be false when both of them are false, right? AND says it should only be true when both of them are true. So this is it. No, don't show me that one. So expressions and operators. I'm going to go to AND, right? Unary, bitwise. This is AND here. So this is OR that we just look at now, right? OR. This is, so they call it logical operators, all of them, like their family of stuff. So this is AND, right? So, but this is MDN, yeah? And let me convert this to AND operator so I can show you this stuff. AND operator, right? So look at here. That's not what we want to show. It will only be true when both of them are true. That is AND, right? False, this is false, abi? 0 is false. So false, false will give us false. It will only be true when both of them are true. True, true will be true. Otherwise, it will be false. Right? So when we come back here, so the AND operator is like this. It's like this, right? It will only be true. So true and true will give us true. True and false will return false. False and true will return false. False and false will return false. Right? One primary difference between true, OR and the logical operator is that in AND, once the first one is evaluated and it goes to false, the second one is not evaluated again, because it already knows that if one of them is false, it will be false, right? So in AND, if the first operation, first logical operation is evaluated, if the first one is evaluated and and the result, what happened there? And the result is false, JavaScript doesn't bother itself again. It will not bother going to the second one. It will just return false immediately, right? Because once any of them is false, it will just go to false. Ticket. But I don't want to dwell on this because it's not where we are going, right? So let's go away from here. The last one I want to tell you about, right? The last one I want to show you for now for today's class is called modulo operator. The modulo operator, right? What is this operator? This operator, it has another name. It's called remainder. Remainder, right? The modulo operator or remainder, this operator is the one we use when you want to get the remainder of an operation, right? Like revision. So like now, 4 divided by let's not use 4.
7 divided by
5 divided by 2. How many times will 2 go in 5? 2. Remainder 1. This, when you do 5 divided by 2 now, you get 2.5, right? But when you do 5 modulo 2, you will get 1. The remainder is what is going to be returned. How many times will 2 go in 5? Right? What is the remainder? Here, the remainder is 1. Right? The remainder is 1 here. So you can have 13 modulo 4 and you're getting 1 again. Because that's 12. It will go 12, abi? 4 times 3 is 12, remainder 1. Right? If it is 17 and you have 5, it will return 2. Because that's 15 plus 2. Right? If it is 19 and you have what do you have there? And you have 3. That's 18, right? If it is 18, you are returning 0. There is no remainder because 3 in 18 is a perfect division, right? It will return 6. There is no remainder. That is why it is returning 0 there, right? So what can we use this remainder for? What's a perfect way in which you can apply this remainder? What's one way that you think we can apply remainder? One way we apply remainder, we apply it in when we want to get even and odd numbers. Even and odd numbers, right? What is an even number?
2, 4, 6.
How do you define it?
Number that can be divided by 2.
And it is divisible by 2.
And doesn't bring out 0.
And doesn't have a remainder. So when you get 6, right, modulo 2, then you check it. Is it equals to 0? Now, if it is returning true, what does this mean? It means that 6 is an even number. Right? Do you see what I did here? I did 6 modulo 2. It will return 0, right? That 0 is now what I compared with 0 to confirm that if there is no remainder, right? Because what I'm checking is there no remainder? If there's no remainder, it means it is an even number.
Modulo is used for checking even numbers and odd numbers.
It is used to return remainders.
So why did you not say means? What's the purpose of that one?
I'm saying that here, that everything I'm doing here is to check if 6 is an even number. That's what I'm doing here. This one will return 0, like exactly like this return 0, right? When it returns 0, but here we cannot. This is not our test for even number, because even numbers should be divisible by 2 and not return 0. So first thing is it divisible by 2? It's divisible by 2, but here we are not testing for 2 here, so we cannot use this. Here we are dividing by 2. It is returning 0. We are now checking, is it returning 0? So here, if you do 11 modulo 2 now. Modulo 2, right? It is returning 1. So we can, if now, is it equals to 0? No. Because it is returning false, then we can confirm that 11 is an odd number.
So, website designing now, what is the purpose of this?
What is the purpose of
this?
Of knowing if something is an even number or odd number? Okay, there are several purposes you can use it for. Okay, one thing is this. I'm going to draw out something now. So we use this primarily for if and else statements. That's one where we use it mostly for examples like this. You did Fizzballs the other time. How did you do it?
If and else. I think I did a while loop of the numbers less than 100.
Okay.
So if it is divisible by 3, give Fizz else. Give us.
How did you know if it is divisible by 3?
It will divide it.
And it will return 0.
Yes.
So you are testing for if it is returning 0.
There's still one purpose in making websites. There's something in that book, there's no purpose in making websites.
Okay, there are purposes for it. Currently, don't worry. If you want to know how it translates to how we use it in web design itself, we'll come to that. I'll find some analogies I can use for you. But currently, we are just learning the syntax for now, and then we'll see.
Even the multiplication too, you can also find out as the purpose of multiplying.
Yeah, the purpose of multiplying. But the thing is,
the website is more than multiplying.
You will use it, don't worry. You are wondering how we will use it. Or in website design.
Teaching in school now. Maybe our students now, they were teaching them some maybe further maths in a session. They don't use it anymore. So
they don't use it anymore.
Like this now,
No, it's not like this. It's not like this. You will quickly realize that it's not like this one. Because eventually you will realize that all these are going to be useful very shortly. Very shortly. Once we start building our functionality on our website, you realize that all these are very, very useful. They are going to come in handy. I can promise you that. It's not for play actually. So yeah, so we have all these operations that we have here, right? All these operations that we have here. So what I want you to do as assignment is this. So I'm going to create constant circumference of circle, right? Circumference of circle is what? 2 pi r, right? 2 pi r, that's 2 times pi, right? So pi, I'm going to use Math.pow. So where am I saying the Math.pow from? So all these operations that we have been looking at, there is a mathematical object, math object, right? Math. Note though, it is capital letter M. If you write small letter M, you will see it though. Right? Small letter M, you won't see it. It is capital letter M. So when you open it, you will see a lot of stuffs, right? Mathematical operations generally, right? Like so, when I say math, you have seen pi, abi? So math dot sine, we have sine, not this sine, sin, right? So you sine of 60 degrees.
So this one's like a function.
Yes. So all the mathematical functions in your calculator, this thing can do it for you. Right? All those things that you have in your calculator, they are already here. If you want to do square root, right, in your normal calculator, right? So here we have Math.sqrt for square root, right? So here I can just pass in 87 and it will do the square root of 87 for me, right? So we have all those stuff inside here, right? etc like that. Math.power to raise to power. So Math.power to raise to power. So you say 2 raised to power 9, right? 2 raised to power 9, and you are going to get that. So this is mathematical operations too, right? They are embedded into all those stuff. So now that we have all this stuff, so let's go back to circumference of a circle. So constant circumference, I'll just use say for now. Circumference of circle, right? That's 2 times Math.pi, right? Can you see here? Pi is a constant, right? If you look at here too, all they are constant. They named it capital letter. E is a constant, capital letter. Log E pi sqrt of 2, that's square root of 2. Square root of 1 over 2. This is square root of 1 over 2. This is square root of... Because, do you remember when I was talking about if you are going to have constants, you should use capital letter to name them as your convention, right? Naming convention. That is why they are using capital letter here. Because what? Their values are not going to change throughout the lifetime. The square root of 2 is going to be 1.141414 every time.
This kind of, you cannot use let.
You cannot use...
Let.
This one is set in stone. You are not changing it. Just use it directly. You cannot change it. You cannot say Math.pi now. You now want to set it to another thing. It is already an object of that. If you change it, you are changing mathematics, JavaScript stuff. So constant circle, circumference of a circle, that's 2 times Math.pi. Math.pi, right? 2 times Math.pi times R. And that's the one we don't have, Abby.
You mean
The radius. Math dot, so let's just use 5, something like this, right? So C will now be this. Makes sense. Where we are just using multiplication 2 times, Abby. We have volume of a cylinder. Volume of a cylinder. Volume of a cylinder, right? You don't need to cram them. We are just using an example. This is what volume of a cylinder is. We have pi, right? We have square, right? That's power.
Yeah.
And then we now have h, right? But this is not what I want. Volume of a cuboid. Of a cuboid. I think this one is much more complex. Where is it? Where is the formula?
Width, height, and length. That's it.
No, that's too simple. No. Area and volume of a cuboid. Why is this so simple? It's too simple. I'm looking for a complex. I know there is one that is 1 all over 3 times height times length times width, something like that. What is that? How to solve this? Why is this prism? What is prism, right? Volume. Using volume. Yes. What is prism volume? What is this? Where's the formula?
Based on that.
Why? Area core. This is weird. Okay, I know what to do. Yeah, I know what. Let's just go back here. So the 2 assignments I'm going to give you. Where is that place? First, this is not it. Where are we working from? Okay, here. So let's do it with pi r square. Pi r square is what? That's pi times r square, right? So that's what? Constant. No, not here. Constant. What's pi r square again? Area of a circle. Is it area of a circle? Pi r square. Pi r square is what? Of a circle. Yeah, it's correct. So pi r square. So area of circle, right, is equals to pi. That's Math.pi, capital letters, right? R square. So that's power. So I have to use Math.pow, right, into R. I'm going to give it 4 or something like that. Square is what? So here I'm not going to do it like this. I'm going to give it 4 for now, right? Square is raised to power 2, Abi. Yeah. So area of circle should hold what? That value now, right? But we are not going to do it like this now. So originally, if you want to design this, So I'm going to say constant radius. Radius can change, right? So let radius to be equals to 9. It can change. Then I will just be calling area. Let area of circle, right, should be the same thing as math.py, right? Math.py times math.pow, right? Now, instead of putting the number directly, I'll pass in radius, and then I'll pass in what? 2. Do you see what I'm doing here? So that if the radius changes, I don't need to change anything again. I'll just call A of C and I'll get this. I can call AOC, that thing again. I don't need to redeclare it again, right? I'll just call AOC now. Before I call AOC, I'll call radius. I'll give radius another value. Instead of 9, radius is now 87. Then this guy, I don't need to declare this one again, Abby. So radius is now 87, right? So I'll just press enter now, and then I'll get this, right? So using this last approach, I want you to write the expression. Write the expression, right? For the same way we wrote the expression for area of circle. So write the expression for area of scalene triangle. Scalene triangle. You can find it. You go and check online, or area of scalene triangle, right? That's one. And then write the almighty formula using those. So let me show you. Scalene triangle area. Scalene. This is not it though. This is not it though. Is this scalene triangle area? Where is it? Something like this. 1 over 2. This is what I want. This one. This one. This is it. This is what I want here. Area of scalene triangle using Aaron's formula. So let me put it so that you don't forget. Area of using Aaron's formula. Area of scalene triangle using Aaron's formula. So let me put the formula in front of it for you. Where is that in again? Where is that in again? Let me put this in front of it. So this is how you are going to write it. You are going to write this expression just like this, right? And then so the S will be separate, so that when you change the value of S, that area will change. A, B, C too will change. So, and then this is the formula, quadratic.
Is it quadratic or Math formula?
It's only Nigeria that they call it almighty formula.
Okay.
This is the expression, right? This is the real thing, right? The formula, that's what they call it, quadratic formula. That's the real name.
What do you use it for?
Eh?
What do you use it for?
Which thing? This thing. You use it to make predictions now.
Predictions.
Yes. You need in finance when you are Bitcoin. You don't read their map, their graph. In forex, they use it in Bitcoin. They use it in forex. They use it to make financial models.
So you can use it to know whether the map go up or down.
Yes, now.
That's it.
Yes, now.
So
This one is a very even simple. This one is a quadratic equation, right? Those ones are not quadratic. Those ones are polynomials. Base 5, base 6. If you don't know this thing, you cannot do forex. So
I don't know that you can use a Math for that.
that's just even one. If you are a scientist and you go to all these people, what is it called, doctors, they use it to read patients' body, whatever, right? From the data that they collect from patients, this is how they are going to know if you are about to die, because there are thresholds that you must not pass. The behavior of this graph, in your hospital, where they hook somebody up and that thing will be ping ping ping. What's that thing? That's a sinusoidal wave now. This is it now. Is it easy? That thing is sinusoidal wave. That thing must not stop as it's going like that. It is reading your heartbeat, and they are using to check is your heartbeat. If it goes flat, it means your heartbeat is no longer consistent, and you are no longer beating. If it goes above a range, then you are having hypertension. If it goes below a range, hypotension. And now, so it is important that they are reading in real life as you are breathing and your body expression is moving, right? So all these things is not for play. It has real life implications. All the people that are doing forex, that they are saying they want to predict how the dollar will change against the naira. This is what they are reading. Yes, now this is what they are reading. Now if you go into the banking hall and you will see that it's scrolling, this is what they are reading. This is what you'll be reading, and it is from these data points that you can now make your inference.
So I told this I can know whether that will go up
And
or
now,
whether it go down.
and then no, when you see it now and you see it going up, then it is you that from your knowledge of finance, you now use it is going up. Okay, from what I know about finance, then you can now relate the two and learn and then make your decision from there. They use it in forex, crypto. I've just talked to you about medicine. If you are a data scientist and you are collecting data from farm, all these are Greek people, right? They want to know if their crop is behaving normally. This is the kind of plot they are going to plot now. Anyway, so this is the formula, the quadratic formula. Yeah, this one. So this quadratic formula now, I want you to replicate this in JavaScript like this in our AOC. So the same thing like the scaling triangle. So the B is a variable, so you have to declare it separately. Let, so that we can change it the same way we can change. The A is a variable, the C is a variable. You have to change it so that when you change the value of B, the value of X will change. When we call X back, the same way we are calling AOC back, and the value is changing, the value of X will change. When we change C and we call X, the value of X will change. It is like that.
So use let and const just now in the same thing.
Yeah.
Can you use let and var like that?
You can use let and var. In this class, we are not using var at all, but you can use it together. You can use it together. Just know that if you use const, once you set the value will not change.